Ever had a conversation with an AI and then asked it something from last week? Hey, remember that thing we talked about? And it's like, what thing? Yeah, we've all been there. But what if your AI could remember? Not just hold a few sentences in its working memory, but actually store and use information over time, like humans do. That's the future researchers are building. And today, we're diving into a breakthrough system called MIRIX. Let's break it down. So here's the problem. Most AI assistants today are stateless. They don't actually remember anything beyond the current conversation. If you ask them about a previous interaction, they're basically clueless. But humans, we rely on memory to learn, adapt, and have meaningful conversations. That's where MIRIX steps in. MIRIX isn't just about storing data, it's about smartly organizing it. Think of it like a brain with different types of memory. There's episodic memory, which stores personal experiences, like that time you asked for recipe suggestions. Semantic memory holds general knowledge, like the meaning of words or concepts. Then there's procedural memory, which remembers how to do things like solving a math problem. Plus, resource memory for files, knowledge vault for critical info like addresses, and core memory as the hub for everything else. But here's the kicker. MIRIX doesn't just store information, it roots it. Imagine 6 specialized agents working together, like a team of librarians. One handles your preferences, another tracks your tasks, and a meta manager decides where to file each piece of data. This structure makes retrieval faster and more accurate, even when dealing with complex multimodal inputs like images or videos. The results? Mind-blowing. In one test, MIRIX outperformed existing systems by 35% on a tough benchmark that required analyzing thousands of screenshots. It even cut storage needs by 99.9%, like packing a library into a tiny box. On long conversations, it hit 85.4% accuracy, far ahead of the competition. But MIRIX's real innovation lies in its approach to training. Let's talk about the dataset. Most texts are just 9,000 characters long, about the length of a short social media post. Training an AI on the entire dataset at once is like giving a student a cheat sheet before an exam. They'll ace the test, but does that prove they understand the material? Enter MIRIX. Instead of brute forcing the data, it uses smarter memory strategies to match that cheat sheet performance without the shortcut. Think of it like a student who studies efficiently, not just cramming. Other methods like ZEP struggled, with researchers suspecting implementation bugs. Systems like LangMem or Memabase showed promise, but couldn't match MIRIX's consistent results. Why does this matter? These experiments aren't just about speed or efficiency. They're about building AI that can handle real-world tasks, like remembering your favorite coffee order during a chat, tracking a multi-step project, or learning from past mistakes. MIRIX's success hints that we're getting closer to machines that don't just process data, but retain and use it smarter. Next time you chat with an AI, ask yourself, what's it remembering and what's it still learning? The future of smart machines might just depend on solving this memory puzzle.